So here we shall explain the concept of a subset and superset with some examples. So the definition is that a set A is said to be a subset of a set B, if every element of the set A is also an element of the set B. If every element of the set A is also an element of the set B. So this can be written symbolically. That is that if A is a subset of B, then this implies, or I can say, if and only if every element, if and only if A belongs to A also implies that A belongs to B. So A is a subset of B if and only if A belongs to A, it means A belongs to B also. And if A is not a subset of B, A is not a subset of B, then it is written as A is not a subset of B. And there is a rule that if A is a subset of B and B is also a subset of A, then this implies, it means that if and only if A equals to B. So if A equals to B, I can say that A should be a subset of A and B also should be it's A also should be subset of B and B also should be subset of A. And there is the second rule, that is that the set A is a subset of itself. Set A is a subset of A. It means that every set is a subset of itself. So actually the fact is that if A is a subset of B, then it can be represented in the form of a Venn diagram as this is the set B, then A is a part of this set B. So this is set A, which is inside the set B. Then I can say that A is a subset of B. So we can understand this concept by some examples. Suppose we tell that the set of rational numbers, set of all rational numbers, should be a subset of all real numbers. Set of all rational numbers, set of all rational numbers is obviously a subset of all real numbers. Subset of all real numbers. It means I can say that the set Q is a subset of R. It means that the set of all rational numbers, which is set Q, is a subset of all real numbers, which is R. So Q belongs to R. So no, sorry, Q is a subset of R. Okay. Then another example we can give, that is suppose A is the set of all divisors of 56. Set of all divisors of 56. It means that all factors of the number 56 we have to write. So which is 1, 2, 4, then 5 we can't write, 7, 7 8 is 56, then 4, So 4 the 16, 14 4 the 56, then 228 the then 56. So this is the set A. And the set B is that the set of all prime divisors of 56. Set of all prime divisors of 56. So that will be, so 1 is neither prime nor composites. So therefore 2 and 7. 2 and 7 are only the prime numbers, which are divisors of 56. So here we can say that 2 and 7 also belongs to the set A. So therefore B is a subset of A. And then one more example we can give, that is, let the set A is the set of all vowels of the English alphabet, that is A, E, I, O, U. And B is the set of, B is the B is the set that contains A, B, C, and D. So now that all the elements in set B are not of the set A, so it means that A is also not a subset of B and B is also not a subset of A. Then there is a definition called as proper subset. So let A and B are two sets. Let A and B are two sets where A is a subset of B, but A is not equal to B. Then A is called a proper subset of B. Then A is called a proper subset of B. A is called the proper subset of B, and B is called the superset of A, and then B is called the superset of the set A. For example, suppose I have the set A is suppose 1, 2, 3, and B is the set which contains the elements 1, 2, 3, 4, 5. So it means that A is a subset of B. Since the whole set, the entire, since all the elements of the set A are also contained in the set B. So A is a subset of B and A is not equal to B. That here A is a subset of B and A is not equal to B. Okay. Then B is called the superset of A. Then there is one rule that if a set A has only one element, then it is called as a singleton set. Then it is a singleton set. A has only one element, then it is called singleton set. For example, if I tell the set, suppose 3, so this is a singleton set. So then we can understand one more example. Suppose we consider the sets phi A, which is equal to 1, 3, and B, which contains elements 1, 5, 9, and C, which contains the elements 1, 3, 5, 7, 9. So now here, therefore, we can see that A is obviously a subset of C, and B is also a subset of C, and phi is the subset of all sets. Since phi is subset of A, phi is subset of A, B, and phi is subset of C also. Phi, okay. Since phi, the null set is a subset of every set. Null set which is phi is a subset of any set. It means here we can see that A is not a subset of B. Since by here only the one element, the element 1 is common to A and B, but the remaining are not the same. So A is not a subset of B. A is a subset of C since why 1 and 3 are also there in the set C. Okay. So hope you have understood the concept of subset and the superset. So here, for example, we can say that A and C are not the same. A is not equal to C, but A is a subset of C. So here A is, so here A is a proper subset of C. A is a proper subset of C, and C is the superset of A. C is the superset of A. So hope you have understood the concept of subset and superset. Thank you.